we classify them, think about your number line, yeah? It's a real number line, which means that every number on the number line is real. We don't include the complex number system. Well, all of those numbers can be classified into two groups. They are either rational or irrational. And if you're a rational number, then you can be made by dividing two integers. You can be written as a fraction, basically. Every rational number can. So examples would be 0, or maybe negative 1/3, or 100. These are all examples of rational numbers. They can all be written as fractions. And they're either positive or negative. Now, if you are an irrational number, you cannot be written as a fraction. Okay, you are not written in fraction form, nor are you a repeating decimal. Okay, irrational numbers are decimals that never repeat and that never end. So examples, common examples I should say, are the square root of 2 and pi. Those are the two most common irrational numbers that we talk about. And again, they cannot be written as a fraction. They are decimals that never end and that never repeat. Okay, so we haven't talked about it yet. Next week, we're going to jump into some applications with exponential and logarithmic. But one of the ones we're going to see is compounding interest. And so here's the formula for it. A sub f. Any little value down in the bottom right-hand corner is considered sub. You don't need to know what all these letters stand for, but I'm going to tell you right now just so you know they do have a purpose. Okay. A sub f just means our final amount. What's the end after our time period? P is the principal amount. What did we invest into this account? R is the rate. What is the percentage at which the interest is compounded? N is how often. So is it compounded daily? Nah, you wish. Is it compounded yearly? Most likely. And then T is how many years you've had the account. Okay, so A, P, R, N, and T all have reasons. We'll say they all have values or reasoning to be in this equation. But what happens when we simplify the equation? Let's set P, R, and T to 1. If we do that, what's the only variable that we're left with? N. So how often it's compounded, right? Well, do me a favor. I want to plug in the values down here. So I want us to plug in 1 and 10, 100, 1,000, and so forth. All of these in for N. And I want you to see what happens. What happens to the value? So please work together. If you want to split the work, that's totally fine. You'll definitely need a calculator. But substitute 1 in for N and record what you get. And then 10. And then 100 and so forth. And when you're rounding, round out to the third or fourth decimal place. Yeah? And then we'll see what you get and we'll see what we can conclude from there. Okay? All right, so if we substitute 1 in for N, we get 2. Nice number. Beautiful little integer. What about for the next one? What'd you get?
2.59.
Nice. 2.59. And I'm just going to go out a little bit further. So 2.594. For 100, we should have gotten 2.705-ish, yes? Now again, if you rounded to 2 decimal places, that's fine. 3, that's fine. For the next one, 2.717, yes? Okay. And then 2.7181, yes? All right. Well, it seems like we're getting a little bit closer to a specific number. What do you think we're getting close to here? Huh?
2.78.
2.7 what?
8.
8, maybe, yeah. Other suggestions? Okay, 2.7189. Maybe. Okay, if we substitute 100,000, we get, and I'm going to go out a little bit further than you guys did, 2.718268237. Man, there's still that 2.718 though. Okay, for the next one, we should have gotten 2.718280469 approximately, yes? So then if we substitute in 1 billion, we get 2.718281693. What are we leveling out at? What does it seem that we are approaching here? Yeah, Peyton. 2.718, absolutely. I would like to introduce you to an irrational number we're going to use a lot next week that is super helpful with natural phenomenon like exponential growth and decay. Okay, our interest formula that we'll see also. And that is the irrational number of E. It is not just the first letter of the word elephant, my friends. It has a numerical value. Who knew? So now we can add that to our list of irrational numbers. It's E. We normally approximate it out to be 2.72 is what you'll see a lot of times. If you look on your graphing calculators, for those that have it, on the right-hand side, you know how we have that upside-down V, the little caret? What is the second function for that button? Pi, right? If you go below it to the division button, what is its second function? E. So if you hit second division, there we go, and you hit enter, it will bring up the decimal for E for you. Fancy, right? This will be very helpful. But for now, we're going to graph it. Doesn't that sound like fun? Yes, Lauren's eyes of doubt and skepticism say she's ready. All right, take a look. Here is our parent function for e to the x. Is this exponential growth or decay? Growth, right? How do we know? Not positive. The base is always positive. How do we know it's exponential growth? Stephen?
The A value is positive?
No, but good guess. Thank you. Lauren? No, not the exponent. Good guess. Will?
Well, I'm just going to say that the exponent isn't like affected by any type of.
Yeah, what Lauren said, but I appreciate that. How do we know if it's exponential growth? What's raised to the exponent? The base. And E is what in relation to the number 1? It's greater than. So this represents exponential growth simply because the base is greater than 1. So why does this matter? Because we know that when graphing, it's going to increase from left to right. It's going to give us exponential growth. And for an exponential function, does that have a horizontal or a vertical asymptote? Exponential functions. Courtney? Horizontal. Okay, they have horizontal asymptotes. And how do we find them? Where are they located? Are they A, B, H, or K? Y equals, think about what a horizontal asymptote is, yeah? What's the only thing that's going to shift me? K, good. Because if it's H, you're moving me left or right. I'm still here. But if it's K, then you're shifting it up or you're shifting it down. So that's going to shift where your asymptote is. Yes, it's going to be Y equals K. All right, well, for every parent of an exponential function, we have a set of points, yes? Yes. So let's make our X and Y table. And we're going to start with 0. What is anything to the 0 power? 1. Okay, there's your parent table. That's all we're graphing. And the reason being, what is E? Again? 2.718 or 2.72, that's going to be kind of a headache when we start adding all these different transformations. Yes, I would love for you to multiply that by 1/3 and then add 5. No, that's terrible. So when we're graphing base E, the only point that we're actually going to transform is the point 0, 1. From there, we're going to have to analyze the transformations and see if we hold this shape or not. Okay, so here we go. Oh, whoopsies. What is our horizontal asymptote, by the way? Good. Y equals 0, because there isn't a vertical shift. Okay, so go ahead and draw in your asymptote. Plot your point. And keep in mind 2 things. This is exponential growth. We are increasing as our graph goes from left to right. Second thing, we don't cross the horizontal asymptote, but we get really close to it. It's our guide. Knowing those 2 things, I'm going to go ahead and draw my graph. What matters is that you have that point 0, 1 representing there are no transformations. You have the horizontal asymptote. Our curve represents exponential growth, and it gets close to the asymptote. What's the domain? All real numbers. Does that ever change for an exponential function? It does not. What's the range? Nice, 0 to infinity. Y is greater than 0. It does not include 0. Okay, so that's e to the x. Well, let's look at its inverse, because when we graph our exponentials, we know that we can graph the inverse logarithm with the same base. For example number 2, ln. Anybody know what that stands for? Tori? Log base E. Nice job. Anybody know what that's called? Jack? Natural log. Good work, you two. Some people are uncomfortable with the ln notation. It is read natural log. It does have a base of E. So if you don't like the way that looks, you can definitely write it as log base E of x, if that helps you. They are exactly the same. It doesn't matter what format you write it in my opinion. Okay, so this is a logarithmic function. It is the inverse of the exponential, which means that instead of having a point at 0, 1, we're going to have a point at 1, 0. Good. Instead of having a horizontal asymptote, what are we going to have? Good. So yes, logarithms have vertical asymptotes. Where are they located? At x equals h. Yes, good. So this particular logarithmic function has a vertical asymptote at x equals 0. Good. Okay, so we haven't seen what this particular logarithm looks like. I'm going to do something we haven't really done before. I'm going to sketch its inverse. You don't have to do this. I'm going to do it just for our visual reference. But we know that e to the x looks like that. Would you agree? Yeah, we just graphed it, right? And there's this, I would say property, but there's this idea that we learned in geometry that if you have 2 functions or 2 shapes that have the same points, but their x and y values are switched, they reflect across a specific line. Anybody remember that? That was a while ago. Courtney? Ah, very good. If you have 2 functions whose points, whose x and y values switch, thus our inverses, they are reflected across the line y equals x. So I'm going to go ahead and just sketch that in, because this is going to help us determine the shape of the natural log function. I'm only doing this once because we haven't seen it yet, all right? Now we know that the natural log of x has a vertical asymptote at x equals 0. So I'm going to go ahead and draw that in. We know that it has a point at 1, 0. The thing we don't really know is the reflection, or sorry, the shape of it. So we're going to use the reflection to help us build the shape. It should get close to the vertical asymptote, and then it should extend to the right so that it is a mirror image across y equals x. That is the shape of the natural log of x. Do you have to do this every time? No, but I think it's a nice introduction to what the shape should look like. What's the domain here of the natural log of x? Nice, yep, x is greater than 0, which means it's 0 to infinity. What's the range? Good, all real numbers or negative infinity to positive. Okay, now that we have our parent functions, let's play around a little bit with the transformations. Keep in mind, we're only transforming one point, and then we'll just sketch in where the curve should go. Take a look at example number 3. Okay, right away I see we're dealing with an exponential function base of e. I also see that there's a b value. Eek, what do I need to remember to do? Factor it out. All right, let's factor it out. We still have that 3 on the front end. Times e to the 1/2. When you factor, what mathematical operation are you using? Division. Good. So let's divide that from -1. We get -2 and then -1. All right, identifying our transformations. A is equal to 3. So what does that mean for us? Huh? Vertical stretch. Nice. Thank you. Vertical stretch. The b is 1/2. Is that how we put it into the transformation table? What do we apply? The reciprocal. Nice, everybody. So 2 is going to be in the transformation table, which means we take a horizontal, what? Stretch. H is a positive 2 because we always take the opposite sign of the h, so we go 2 units to the right. And k is -1, so we go 1 unit down. Well done. This is an exponential function. So do we have a vertical asymptote or a horizontal? Very good. Where's it at? Not just -1. Y equals -1. Don't forget the equation, please. Now, for those who maybe forget what the transformation table setup should be, I'm going to put it at the top for us. It's the reciprocal of b multiplied by our x values, and then we add or subtract h. We take a and multiply it to y, and then we add or subtract k. This has been the same all year, and I promise you it will not change. Okay, this is the transformation table setup that we use. So let's set it up. Our reciprocal of b is 2. So we have 2x plus 2, since that's our h value, and then 3y minus 1. The only point that we are going to transform is what? What's the x value? There it is. Okay, 0, 1. So if we plug in 0 for x into the table, we get 2. If we plug in 1 into the table for y, we get 2. Okay, here we go. Putting it all together. Our asymptote is at y equals -1. The point we found is at 2, 2. Now remember, e to the x represents exponential growth. It increases from left to right. Do any of these 4 transformations affect our graph increasing from left to right? What's the only 2 transformations that would? What would affect this? Steven?
Negative A or negative B.
Yes, nice work. Any reflection. If A is negative, right, we're reflecting over the x-axis. So I have that now changed. If A is negative, it's vertical. If B is negative, what am I? Horizontal. So now we have decreased. The only 2 transformations, you might want to write this down, that will change the direction of your graph are the reflections. Okay, the only transformations that will change your graph from increasing from left to right would be a vertical and or horizontal reflection. Okay, so knowing that our graph is still going to increase from left to right, we have to include the point that we found, and we're going to get really close to that asymptote, but we are not going to cross it. Graph it in with me, please. Oopsies, wrong color. All right, so I'm going to start out close to my asymptote. I'm going to increase as I go towards that point, and I'm going to extend up. Is it weird only plugging in one point? Yeah, for sure. What's the domain? Excellent. All real numbers, negative infinity to positive. And then what's the range? Nice. Yes. -1 to infinity. Not beyond. Never gets old. Okay. Any questions on example number 3? Okay, I've got one more for us to do together, and of course, it is a natural log. If you need to, please rewrite it as 3 times the log base e. What do we need to do with that b value? Factor it out. So we get 2 times x minus 1, and then minus 3 on the backside. Okay. Let's identify our transformations, see what happens to our graph. Is there an a value? Yes. Thanks, Peyton. What is it? Good. It is 3. So that means we have a vertical what, everyone? Stretch. It's extra important to be able to identify the transformations with these graphs with base e, because we don't have additional points to show what is happening to the graph. So as long as we identify the transformations correctly, it demonstrates we understand what's happening. B is 2. So what are we going to put in our transformation chart? So good. So good. 1/2. So we have a horizontal compression. Very nice. Horizontal compression. What is h? +1. So that means we're going to go 1 unit to the right. K is -3. So we're going to go 3 units down. What type of asymptote do we have here? Vertical, very good. And where is it? At x equals 1. Okay, looking good. Let's set up our transformation table. We have 1/2 times x plus 1, and then 3y minus 3 for the y column. What's the point that we're transforming?
0.
Very good, 1, 0. If we substitute in 1, we get 1.5. If we substitute in 0 for y, we get -3. Okay, let's plot those, well, the 1 point and our asymptote. Let's draw that in, and then we'll talk about the shape of the graph and see if there's any sort of change we need to think about. Okay, a logarithm with base e normally looks like this. Are there any transformations that will affect the direction of the graph? No. What are the two transformations that would? Very good. Vertical and horizontal reflection. So we're going to get really close to that vertical asymptote, and we're still going to increase from right to left. What's the domain? Good. 1 to infinity. So x is greater than 1 or, and I'm super impressed you guys have all been using the interval notation today. Great job. What's the range? All real numbers. Yay. Whew! Any questions on natural log? All right, now your homework, we've done the first 2 problems, right, from the previous notes. I'm adding on, there's 4 graphing as is, but I'm going to add these 2 you try to it as well. So my suggestion would be, in the 10 minutes we have, at least get those 2 done. Yeah, it is posted on your weekly agenda for you though. But that's it. If you have any questions, let me know, please.